All right, and the third thing we want to look at is how to solve a quadratic equation when it's written in its standard form. So there's different options here, and we're going to look at option A only for this lesson. We're going to write the quadratic equation first in its factored form, and then use what we did with the factored form. We're going to set each factor equal to 0 and solve the mini equations. So here's my quadratic equation, one variable only. I have it equal to 0, and because it's equal to 0, I can work at factoring that. So first I look for a common factor. There's nothing common to all three terms. Then I look at the fact that there's three terms with a 1 in front of the x squared. So that is our simple trinomial. We'd be looking for two numbers that are going to add to the middle term of -4 and multiplies to -12. The a is 1, the c is -12. 1 times -12 is -12. So factors of 12 would be 1 and 12, 2 and 6, 3 and 4. And because we're multiplying to a negative, one of those two numbers is negative, and because we're adding to a negative, the larger number is negative. And the combination that works here is the 2 and the -6. So our factors, because it's a simple trinomial, will be x plus 2 and x minus 6. And that goes just directly into the factored form. I don't have to worry about the decomposition because I only have a 1x. So then my mini equations would be x plus 2 equals 0. Subtract 2 from both sides, x equals -2. And then x minus 6 equals 0, x equals 6. So my two solutions to this would be -2 and +6. All right, part B is very similar to part A, except I don't have equals 0. I have equals 21. So our first step will be to get 0 on one side of the equal sign. And to do that, I'm going to get rid of that 21 by subtracting 21 from both sides of the equation. So we end up with x squared minus 4x minus 21 equals 0. Check for a common factor. No, nada. Three terms. A 1 in front of the x squared. I'm going to look for two numbers that add to -4, but this time multiplies to -21. So 1 times 21, 2 doesn't go in evenly, 3 and 7 multiply to 21, 4 doesn't go in evenly, nor does 5 or 6, and we're back to 7. So those are the only two integer combinations we have for that. Multiplying to a negative, they're opposite signs, and the bigger number is the negative because we're adding to the negative. And here's the combination right here. So my factors are x plus 3 and x minus 7. So those two things have to multiply together to give you an answer of 0. The only way they will do that is if either the x plus 3 is a 0, which means x equals -3, or it means that x minus 7 is equal to 0, which means x equals 7. So those are our combinations or values of x that will make the equation true. So if I actually took -3 and subbed it into the left side here for the x, -3 squared would be 9. 9 take away, and then 4 times -3 would be -12. So 9 take away a -12 would be adding 12. 9 add 12 equals that 21 that we have. If I put a 7 in for the x, 7 squared is 49, minus 4 times 7, 49 minus 28, yep, equals 21. So we know that those answers work. All right, so the key idea with that is you want to make sure you have to get 0 on one side of the equal sign before you can begin. And by begin, I mean actually factoring it. So in part C, we need to do that very step there. We're going to have to get 0 on one side, so I'm going to subtract 4x from both sides of the equal sign. That's going to leave me with an x squared minus 4x equals 0. And then I'm going to look at factoring. First of all, I want to see, is there a common factor? Why, by golly, there is. There's an x that's common. So we're going to common factor x out of that, and leaves us with an x minus 4 multiplying the x. And now we set each factor. So x by itself is just x. It's its own factor. X equals 0. Think of it like that. And then the other one is x minus 4 equals 0, which means x is equal to 4. So again, that's why we were switching the signs when we were finding the x-intercepts. So two solutions for that. The last one, second last one here, I've got a jumbled mess. I want to make sure I get 0 on one side of the equal sign, so I'm going to add 6 to both sides. And at the same time, I'm going to write that in our familiar descending powers of x. So I'm going to put my 5x squared first. It's a plus. I have plus 17x, so always take the sign in front with it, and then plus 6 equals 0. So I look, is there anything common to all three terms? Sadly, no, there isn't. We have three terms. It's not a nice simple trinomial. It's also not a perfect square trinomial because I don't have perfect squares on the ends. So I'm going to look for two numbers that add to 17, and at the same time they have to multiply to the product of 5 and 6, which is 30. So things that multiply to 30 are 1 and 30, 2 times 15, 3 times 10, 4 doesn't go in evenly, but 5 does times 6, and then I'm back to 6 times 5. So those are my combinations. I'm multiplying to a positive, so they have the same sign, and they're both going to be positive because I'm adding to a positive. And our combination that works is right here. This one, we cannot go directly to the factored form because it's not a 1x squared. I am going to put the 15 with the 5x squared. So 5x squared plus 15x plus 2x plus 6 equals 0. So we've used that method of decomposition to decompose or break down that 17x, and now we group them up for that common factor. Out of the first two terms, they have a 5x in common, and when I divide 5x out of there, we have an x plus a 3. And if I look at the second pair, they have a 2 in common. They can both be divided by 2, and in fact, I'm going to make that a plus 2, positive 2. Leaves me with an x plus 3 when I divide both those terms by 2. And now they have x plus 3 in common with one another. So the factors are x plus 3 and 5x plus 2. And that's equal to 0. So now I can set my factors equal to 0 and solve for x. Oh, thank goodness, I was able to move that up this time. So we have x plus 3 equals 0, which means x equals negative 3 by subtracting 3 from both sides. And this one was 5x plus 2 equals 0. We're going to subtract 2 from both sides, and we get 5x equals negative 2, and then divide both sides by 5. X equals negative 2/5. All right, last example here. Again, I don't have 0 on one side, so I'm going to make it so I do. I'm going to write that in descending powers of x. First step, after we get the 0 in there, we want to see, is there a common factor first? And I see all the numbers are even here. In fact, that is a common factor of 2. Everything can be divided by 2. I couldn't go bigger than that. I did look to see if 4 would work or 6, and unfortunately the 14, 4, and 6 isn't going to work with that. So 2 is our biggest. Pull that out. Now what I have in that bracket is a tricky trinomial. 3 terms without a 1 in front and not perfect squares. So I'm looking for two numbers that are going to add to 7 and multiply to negative 18. Remember, the 18 comes from 6 times negative 3. So 1 and 18, 2 and 9, 3 and 6. 4 doesn't go in, 5 doesn't go in, and we're back to 6. Opposite signs, the bigger one this time is positive because we're adding into a positive, and here is the combination that works. So I'm going to decompose the 7x to be a minus 2x and a plus 9x, and then we have our minus 3. So that got decomposed, and now we're going to pair them up for that common factor. 2x is common. 3x minus 1 is the factor, and then out of the second pair, plus 3 is common. We're going to have a 3x minus 1 again. That's good because we need those brackets to be the same. So we have a 3x minus 1 here and a 3x minus 1 here, which is our common at this point. This 2 just keeps getting copied down here. We're going to have our 3x minus 1 multiplying our 2x plus 3. And that's equal to 0. And the only way that's going to equal 0 is if one of those factors is equal to 0. So 3x minus 1 equals 0. Add 1 to both sides. Divide both sides by 3. Or we have 2x plus 3 equaling 0. Subtract 3 from both sides, divide both sides by 2. So x equals negative 3, that should say on the top. Negative 3. Oh goodness, I made a mess. We're making a mess. There we go. Clean it up. Clean up time. There we go. So there you have it. Just make sure you do your factoring. If you do have a perfect square trinomial, I didn't put this in, but I'm going to write one in right now. Let's say you had 4x squared minus 12x plus 9 equals 0. Nothing common to begin with, but it is a perfect square trinomial. These are our two perfect squares on the ends, and if I actually square root the first, and I square root the last, and take my sign from the middle all to the exponent of 2, this would be, if I check the product would be minus 6x. If I double it, I get my minus 12x. This one only has the one solution here. 2x minus 3 would equal 0, or you could write it out twice, but you're still going to only get x equals 3 over 2 as your answer for that. So there's a case where you do only have one solution happening. All the rest of the above examples had two solutions, but there's a case with just one solution. All right, good luck with the questions. If you have any questions, please send me an email and let me know where you're struggling.